illegal number. It's the only one that makes the denominator 0. It looks like that would be maybe C. Does that make sense?
Yeah, that makes sense. Thank you.
Okay, was the number 5 kind of similar to that?
Yeah, it was.
Okay. Anything else from 2.2 or 2.3? I did order a pen, so maybe I'll be able to write on the screen a little bit easier, but it's got delayed, of course. So hopefully by Monday. Any other questions between 2.2 and 2.3? All right.
I don't think so.
Fantastic. So everybody has had a chance to read the syllabus and, you know, kind of think about how exams and quizzes are going to run and all that good stuff. Did you have any questions about the way the course runs in general before we start our new content?
I sent you a message, but my math labs, I couldn't get it to work, but I guess I can talk to you after class about how to get more square on that.
That'll be fine. Just remind me after class is done and we'll look at it. Did it just not take your code or?
Yeah, it wouldn't take my code and
you used the code that was on page?
Yes, ma'am.
Okay.
But since I haven't had math labs or any of these codes before, it's just I couldn't get it to work.
Okay, because you'll probably have to set up an account first. Okay, well, remind me after class and we'll try to look at it for you.
All right, thank you.
All right, anything else? All right, so are you guys seeing a blank piece of paper right now?
Yes. Yes.
Yes, but it looks like there's something underneath it too.
There is, but yeah, it's blank. On this side anyway. Okay, so what we're going to do is we're going to talk about section 2.4. And remember these notes, if you have access to a printer and want to print them off, you are welcome to. They're under modules in your Canvas course. All right, so just for a quick review, if I asked you to take f of x equals 3x squared minus 2x and evaluate f of negative 2, what would you do?
Wherever there's an x, you'd put -2 in parentheses.
Exactly. You go to your f function and everywhere there's the x, which is the input of this function, replace it with -2. So we would just have 3 times -2 squared minus 2 times -2, which would be 3 times positive 4, because we're squaring the negative as well, and then plus 4 again, or we'd end up with 16. In this next section, what we're going to look at is what happens when several functions that we're dealing with. Maybe we want to the sum or difference of two functions, or a product or quotient. So we're going to look at ways of combining functions with multiplication, division, and subtraction. And they're really actually pretty intuitive as far as the way that they are defined. If you want to find f plus g, if f and g are both different functions of x and you want to find f plus g of x, you're just going to take f of x and add it to g of x. And the same concept follows differences, products, and quotients. Now the quotients, you do have to be careful that the denominator does not equal 0. So if we wanted to find f plus g of x, where f of x is 2x squared minus 3 and g of x is x plus 1, f plus g of x by definition is just f of x plus g of x. So in this case, that would be, well, f of x was defined to be 2x squared minus 3. So we'll replace the f of x with 2x squared minus 3, and we'll replace the g of x with x plus 1. And then if we can simplify it a little bit, that's great. That would be, let's see, if we combine our like terms, I just got rid of my grouping symbols there. The only like terms we have are the -3 and +1. So that would give us 2x squared plus x, and then -3 plus 1 is just -2. So it's just like the order suggests up here. When you're adding two functions, you really do just take the terms of the two functions and add them together. Similarly, if you're doing multiplication, this is, sometimes you'll see it with a little closed dot between them. More often for multiplication, they'll just put the functions right next to each other, because what happens is we have another operation that we'll talk about later that gives an open circle there, and sometimes people get a little confused. So oftentimes they'll just put the functions side by side. But by definition, that really does mean f of x times g of x. So for our two functions, that would be 2x squared minus 3 times x plus 1. And what would we do to multiply those out?
FOIL.
FOIL method, exactly. So I'm going to multiply the first terms together, the outer terms together, the inner terms together, and the left terms together. I have 2x squared times x is 2x cubed. Outer terms will be 2x squared times 1. Inner terms will be 3 times x, or minus 3 times x. And then last terms will be minus 3 times 1. So we will end up with just 2x cubed plus 2x squared minus 3x minus 3. Now, does anybody have any questions about this part up to now? All right. So what if we want to find a sum, difference, product, or quotient at a specific x value? Well, it's the same concept. If you take f minus g of 2, it's just f of 2 minus g of 2. You just have to do a little bit more work, because your f of 2 is what you get. Place the x in the function with 2. So f of 2 would be just 2 times 2 squared minus 3, and then g of 2 would be 2 plus 1. So let's see, this would be 4 times 2 is 8 minus 3 minus 3, or overall 2. And then f divided by g of 3 would be f of 3 divided by g of 3. For those two particular functions, I want you guys to try that for a second. Give you about a minute to see if you can get an answer for f of 3 divided by g of 3. All right, does it have an answer?
Is it 15 over 4?
It is. Excellent job. F of 3 is nothing more than what you get when you plug 3 in for x in your f function. So you would have 2 times 3 squared minus 3. And g of 3 is what you get when you plug 3 into your g function. So that's just going to be 3 plus 1. So we do end up with 15 in the numerator over 4 in the denominator. Excellent job. And, you know, we do actually use sums and differences, products and quotients of functions quite a lot. You know, just one of the most basic types of difference of functions would be, you know, if you're in business, revenue minus cost is equal to profit, that kind of thing. All right, so let's do just a couple more examples and then we'll move on to finding the domains of these functions. So if we have f of x is negative x plus 4 and g of x equals x squared plus 2, and we wanted to find f plus g, just be f of x plus g of x, or negative x plus 4 plus x squared plus 2. So that would be, if we kind of put it in standard notation, normally when we write these things in standard form, we put the highest power of x first, and then we go in decreasing powers of x. So I'm going to put the x squared first, then the x, and then we have a 4 plus a 2 is a 6. Now, in this particular case, I just asked for f plus g of x. We could have asked for something like f plus g of 5. Couple ways you could do it. If you don't already have this part, you could go back and say that's going to be f of 5 plus g of 5. Plug those in separately, and you would get f of 5 is negative 5 plus 4, which is negative 1. And g of 5 is 5 squared plus 2, or 20. So we get 20. Or you could, since you already found f plus g of x, you could just do f plus g of 5 in that already simplified function, which would be 5 squared minus 5 plus 6, or 26. So there are a couple ways you can get it, just depending on what you have at your disposal, what you've done, what you haven't done yet. So I want you guys to try just a couple more examples. I'm going to try to make this a little bit bigger there. Sorry. Okay, so I want you guys to try example 3 on your paper, and let's see what we get. All right, so if you want to take f minus g of 2, it's going to be capital F of 2 minus capital G of 2, which will be 4 minus 2 squared for the f, minus G of 2 will be 2 times 2. So it looks like we'll get 4 minus 4 minus 4 as we simplify all the way across. So did you guys get -4?
Yes.
Yes.
Excellent. Good job. Now, in this case, we do have the little closed dot between them, but that's the same thing as fg of 3 or just f times g of 3. And so that will be f of 3 times g of 3. Or the f of 3 would be 4 minus 3 squared, and g of 3 will be 2 times 3. So remember, we have to do the correct order of operations. So I'm going to simplify within this set of parentheses and then multiply in this set. So we have 4 minus 9 is -5 times 6. Looks like it would be -30 in that case. All right, any questions about this particular process before we look at the domains of these functions? And feel free to unmute yourselves and ask. All right. Well, finding domains and ranges is often, one of the more challenging parts of combining functions. There's a lot going on here, it looks like, but we have a couple ways we can determine them. When you have functions, let's just call them f and g, and you want to find the domain of the sum, difference, product, or quotient of those two functions, the first thing you need to do is find the domain of f and find the domain of g. And then the domains of the product, sum, and difference of those two functions will be nothing more than what we call the intersection of the two original domains, or it's what is common to both of those domains. And we'll look at one of those just in a minute. For quotient, f divided by g, it's the same as we found for f plus g, f minus g, f times g, but we also have to leave out the values that make the denominator function equal to 0. So for example, if you have a function f of x is 2 divided by x minus 4, and g of x is x plus 7, let's start by finding the domains of f plus g, f minus g, and f times g. Because these three domains, for any two functions, these are always the same domain. Okay, so step 1, let's find the domain of f and the domain of g. Is actually a little bit easier because the domain of g, remember, domain is just all the legal values for x. So since I'm just taking a number and adding 7 to it, there's not a number that I can't add 7 to and get a number as my answer. So that would indicate that the domain of g is all real numbers. Or we might write it as from negative infinity to positive infinity. Okay? When you're talking about the domain, the legal values for x, I keep saying, those are the values that if you plug those numbers in, you're going to get a real number as your answer. Things that are going to cause you problems specifically are when you have fractions, something that makes the denominator 0, or if you have like maybe a square root of something, you can't have what's underneath the radical be negative because then you don't have a real number answer. All right, so the domain of f, remember we have to leave out anything that makes that denominator 0. And what makes that denominator 0 is 4. So the domain of f is all real numbers and not 4. Okay. Now, the question is, what do these two sets have in common? Well, the domain of G is everything. I'm going to have to scoot down here a little bit, but the domain of G, if you're looking at it on a number line, it would be from here all the way over to here. Okay. And the domain of F is everything except 4. So if this is 4, the domain of F would go this way and this way. So everything except that one number. So the question is for the domain of F plus G, F minus G, and F times G, what do those two sets, the blue line and the red, have in common? Well, they both share every number to the left of 4 and every number to the right of 4. So the only number they don't have in common is actually 4. So the domain of F plus G, F minus G, and F times G would be the set of all X such that X is a real number and X is not equal to 4. Now, if we were going to write that in interval notation, which we will, this book uses set builder notation a bit at the beginning, and then we'll move to interval notation more as we go on. This would be, okay, how far does it go to the left? It goes all the way to negative infinity, and it comes up here to 4. So you could also write this as from negative infinity to 4. Then we pick back up on the other side of 4 and go to positive infinity. So that would be the interval notation way to write that domain. Questions so far? All righty. Now, for the domain of G, or pardon me, of F divided by G, we also have to leave out is the numbers that make the denominator 0. So since we want to find F divided by G, the G function is the denominator. So we need to know what makes it 0. Well, X plus 7 equals 0 when X equals negative 7. So we'll have to take the domain that we found for the sum, difference, and product, and we'll also have to leave out 7. We've already had to leave out 4 because it's not legal in this function. Now we have to also leave out 7. So the domain of F divided by G would be the set of all X such that X is a real number and X is not 4 or 7. Okay. Any questions? I'm sorry, if someone is talking, I can't hear you. Okay, let me see if I can pull up chat. Okay. Now, if I wanted to write this in interval notation, that would be negative infinity to 4, just like it was here, but then we're also going to have to leave out 7 over to the right. So I'm going to go from 4 to 7 and then pick up with 7 and go to positive infinity. Keep in mind when you're doing interval notation that when you put parentheses around a number, that means that number is not included. We wanted to leave out 4 and 7, so I put parentheses around both 4 and 7. And then as far as infinities are concerned, you always have parentheses around the infinities. Okay. All right.
What is that little U symbol in between interval the notations?
That means union. That's kind of the mathematical way to say or. So this means it's either in this set or it's in this set or in this set.
Okay.
Why is it not negative 7? Oh my stars. It is negative 7. I said -7 up there, didn't I? Thank you, Drizka. Scratch that. I can't copy from one line to the next, apparently. That's a -7. Okay. I'm so sorry. So if we're going to leave out -7, as it clearly says right there, and then I just lost my negative sign, we're going to go from -∞ to -7, -7 to 4, and 4 to +∞. Okay. If you don't just lose your negative sign somewhere. All right, so let's try one more of those. We have f of x is 2x cubed and g of x is 4 over x plus 3. So let's look at, first of all, finding the domain of f. The domain of f is going to be all numbers that you could plug in here for x and get a real number as your answer. And if you think about it, if you take any number and you cube it, you're going to get a real number. And then you multiply it by 2 and you still have a real number. So the domain of f is all real numbers. Or as an interval, it's from -∞ to +∞. If we look at the domain of g, this one, well, the top is great. There's no x's to worry about there, but the bottom, we have something that could possibly make that denominator 0. So we have to leave out any x value that makes g of x, or that makes the denominator, in this case, equal to 0. So I'm going to take that denominator, set it equal to 0, and solve. So the domain of g will be all real numbers except -3. So if we write it, we've got the set of all x such that x is a real number and x is not -3. Or if we were going on interval notation, that would be from -∞ to -3, and then from -3 to +∞. Okay. Now, to determine the domain of the sum, difference, product, and quotient of f and g. So the domain of f plus g, f minus g, and f times g. They're always the same. And they will be the intersection of these two domains, or what they both have in common. In this case, since the domain of f is all real numbers, then this domain or this set is included in that one. So we would take the smaller one. But on the number line, if you look at it, okay, the domain of f would be the whole number line, everything on here. And the domain of g would be everything on there except -3. So it would go here and here. And when you're looking for the intersection, what you're looking for is where they're both true. So you have both the red line and blue line. The only that is actually at x equals -3. So the domain sum, difference, and product would be the set of all x such that it is not -3, and of course x is a real number. And we'll look at some examples in MyMathLab here in just a moment, and so you can kind of see how they word the questions. Okay, any questions at this point? I just got the message that my internet was unstable, so I'm hoping you guys are still there. Okay, excellent. We're still here. Nothing like them saying, oh, you may not be broadcasting. Yeah, that's great. All right, now we want to find the domain of the quotient. Okay, I know you asked for it up here again. Okay, so let's find the domain of G divided by F. Okay, the domain of G divided by F is going to be the same as the domain of F plus G, F minus G, and F times G, except we also have to leave out any X value that makes the denominator, in this case, F, equal to 0. Now remember, f of x was 2x cubed. We want to know when that's 0. Well, can anybody think of a number that if I plug in here, I'm going to get 0?
I would say 0.
Perfect. Is that the only one? Well, yeah, if I plug in 1, I would get 1 times 2. If I plugged in -1, I would get -1 times 2, and so on and so forth. The only number that makes this 0 is 0. Now, we'll talk more about actually going through a process to solve an equation like that in a few sections. But what makes that denominator 0 is 0 itself. So we would take the domain that we have here and we would also leave out 0. So the domain of G divided by F in this case would be the set of all x such that x is a real number and x is not -3 and x is not 0. Okay. All right. So I would like to pull up your homework. So I'm going to stop sharing this screen for a moment. And I'm going to share homework and go to 2.4. Let me get this pulled up here. It has to go through little iterations there when I'm pulling up a homework set pop-ups. So are you guys seeing work screen?
No,
section? No, ma'am. Oh, okay. Hang on. Let me get back to that.
I see a dark screen that says Professor Vaughn.
Okay, well, I'm glad I asked. Okay, so let me see if I can get this one up there. How about now?
Yes, I see it.
Yeah, I see it now.
I'm going to mute dog.
Oh, why did
right.
it change?
Did it change?
Oh, no.
Okay, so can you guys see number 4? It says 2.4.19.
Yes.
Okay.
Yes.
So I want us to try this with a few are very similar to the ones that we just this sometimes causes people a little confusion just because they put a B in there instead of just a number, but you don't treat it any differently. So if you had F times G of B, okay, that's going to be, I'm going to try this again, that's going to be F of B times g of b. So let's see. Okay, now, even though that's a B rather than a 2 or a 7 or something like that, how do we find it? Well, you go to your f function, and everywhere you see an x, you plug in b to find f of b. So f of b would be b squared minus 8. G of b, you're going to go to your g function, and everywhere you see an x, plug in a b. So we'll have g of b is 9 minus b. Okay. Now, if we wanted to multiply that out, you'll notice over here they ask you to type the polynomial in descending order. So they do want this multiplied out and put in descending powers of your answers or your input. So I'm going to go ahead and FOIL this out. I'll have b squared times 9, which is 9b squared. Outer terms together will be b squared times b, which is b cubed. Inner terms together would be negative 8 times 9, or minus 72. And then last terms together will be negative times negative b, or 8b. So if I type it in like this, they're going to come back and say, not quite, because I follow the directions to type the polynomial in descending order. So I want to get my highest power first. So I'll start with a negative b cubed. Then I'll go to 9b squared. Plus 8b. And then lastly, I would type in my minus 72. So be careful when you're doing MyMathLab in general. You want to make sure you pay attention to the question instructions, and most often those instructions are in a little blue box or a little blue line below the answer box. Is everybody okay with that one?
I have a question.
Yes.
If we, I know there's this skill builder that's on the MyMathLabs. Do you have anywhere that you record your lessons or anything if we had to go back and go back over it? Do you do anything like that?
What I'm trying to do, and I have your one from Monday in my VidGrid. I know that it's a video editing software within our Canvas classes. And I got it edited down because I had the screen on for way too long. But somehow the closed captioning, I didn't get that cut off yet. But the short answer to your question is I'm working on that. So my plan is to upload these videos inside Canvas so that you could go back and watch them, or if you were sick or something like that, you could see it. So that's my intention.
Okay, good. Thank you.
And I'll try to get on that today so I can get this week's up this afternoon.
Okay, thank you.
You bet. Anything else? All right. So I'm going to scoot on along here if it will let me. Oh yeah, doggone it. Does help if I erase all that stuff. Okay. So let's go to this one. This one, we just have f of x is equal to x squared minus 14, and we have g of x is 20 minus x. And they want us to find f plus f of 4. Okay, so notice they didn't even include the g part in there for the moment. So f plus f of 4 is going to be f of 4 plus f of 4. Now, who can tell me what f of 4 is this particular f function?
Would it be 4 squared minus 14?
Perfect, which is 4 squared 16 minus 14 will be
2.
2. Excellent. So in this case, we would just end up with 2 plus 2 or 4. Well, except my thing quit. Okay, so I'm going to try to just type that in there. See if anything comes up and asks me. Nope, they just wanted that particular part. Sometimes they'll give you another part as you go, but not always. Okay, so let me erase.
Have written down.
Pardon me?
Nothing.
Okay. All right.
Sometimes I feel like you're going too fast. Like I can't solve the problem and write things down as fast as others. And so like I'm halfway through the problem and I don't have the answer, and you already got the answer and moving on. So like I'm not following.
Okay, so you're telling me that I don't pause long enough when you guys are working problems?
I mean, for me personally, I don't know about others, but like I can't do it that quickly.
Try to pause a little bit longer for doing when you're working on problems, and see if we can get it a little bit better for you that way.
Because like I had like written down the problem and then I was trying to solve it, and you're already on to 43.
Okay.
And I didn't even like, I don't even know.
Well, you will
Okay.
be able to go back and check that, but absolutely, I will do my best to give you guys, if I'm asking you to do a problem, I'll do my best to give you guys a little bit more time. Okay?
Okay.
All right. So if we do look at number 43, well, it's actually number 9 of your homework, but what this number up here means, are you guys still seeing number 43? All right. So
Yes.
what this number up here means is that this particular problem is found in section 2.4, and it's number 43 from the book. So if you had a hard copy of the textbook, or if you were looking in the textbook at where you would find this problem, that's where it would be. Okay, so on this one, we want to find, let's see, we are given f of x is 9x plus 5 over x minus 3. So what I'm going to do is, so that it'll take me a little bit more time too, is I'm just going to write this problem down as well, and then when you guys are working on it, I'll switch over to the paper view so that we can kind of work on it together. All right, so we have two functions, and we have f of x is equal to 9x plus 5 over x minus 3, and g of x is equal to 9x cubed. And what we want to do is we want to find the domain of f plus g. And what they did was they said the domain of the sum. So that's why I knew that it was going to be f plus g, at least to start. And want us to do the difference and the product. I'm going to find the domain of f plus g, the domain of f minus g, and the domain of f times g. Now, before I switch views, do you guys have that part written down?
Yes.
Yes.
Excellent. Okay. And you'll be able to see it on screen as well. When I can't, I'm so sorry, y'all, because when I can't read your faces and I can't see when you guys are done doing something, sometimes I feel like I'm just waiting, you know, a really long time when it's really not. And so I miss being able to do what you're doing. But all right. So do you all see this? I have that problem written down.
Yes.
Excellent. Okay, so remember to find the domain of f plus g, f minus g, and f times g. The first thing we want to do is we want to find the domains of the original two functions. So to find the domain of f and the domain g. Okay, so I'm going to sit here for 3 minutes and let you guys work on the domain of f and the domain of g. And if you get those done and want to, you know, go on to the other parts, that's fine. But I'll ask you about progress in 3 minutes. All right, are we making progress?
I personally am a little stuck on some stuff.
Okay. How about we start with the easier one first? Does anybody want to tell me what they got for the domain of G?
Is it all real numbers?
It is all real numbers. Excellent job. Because remember, if you're looking for the domain, it's just what are the legal X values that you can plug in here. And by legal, what I mean is if I plug it in for X, do I get a real number as my answer? And so if I plug in any number you think of, positive, negative, 0, and you cube it, you're going to get a number back, and then you can multiply it by 9 and still get a real number. So the domain of G is indeed all real numbers. Now, the domain of F is a little bit tougher, I think. So we've got two things added together over here. What about this part? Are there any restrictions on 9 times X? No. So any number you take, you can multiply it by 9 and get a number as your answer. So this part has no restrictions. Okay, but what about that 5 over X minus 3? Well, the top part doesn't have any restrictions. It doesn't even have an X involved. But what about the bottom part? What do we have to leave out? We have to leave out
3.
whatever makes the denominator, which exactly is 3. So this part, the domain would be anything, but for this part of this function, we would indeed have to leave out 3. So the domain of F would be the set of all X such that X is a real number and X is not equal to 3. Now, those are the two domains of the original functions. To find the domain of F plus G, F minus G, and F times G, we're going to figure out what they have in common. So if you look at the graph on the real number line of the domain of G, it's the blue line. It's the whole thing. And then for the domain F, it's everything except 3. So we'd start at 3 and go to the left, and we would start at 3 and go to the right. So for what we have in common, or what we call the intersection of those two sets, we're looking for where we have a blue line and a green line. The only place we don't have is exactly at X equals 3. So the domain of all 3 of these combination of functions would be the set of all X such that X is a real number and X is not equal to 3. Any questions about that one? All
So as
right.
long as they don't equal 0, then it's going to be all real number. All.
What do you mean
Wait,
as
hold
long
on.
as they don't equal?
So, hold on. I confused myself for a second. So it can't equal 0. So we have to do every number on there except for where it will equal 0.
The denominator can't equal
I'm confused.
0.
I'm sorry.
It's the denominator part
Yeah.
that can't be 0. That's what you have to leave out. Yes. So if you
Yeah.
had 2 or 3 denominators, we might have to leave out more than one. We might have to leave out more than one X value. For example, if you had a function like, say, f of X is equal to 5 over X plus 2 times X minus 1. If I asked you for what the domain of this function is, it would be the set of all x such that x is a real number and x is not equal to, well, from this factor, x can't be -2, because if you set x plus 2 equal to 0, you get -2, so we can't have it equal -2, and it also can't equal +1 from this factor. So any x values that make the denominator of your fractional function equal to 0 have to be left out of the domain.
Okay, so for g of x, 9x cubed, could the x also be 0?
Yes,
Because
because
it says
if you
it can't be 3.
now the 3 is from the f function. We had to leave it out from the
Oh,
f
okay.
function. The domain of G is all real numbers.
Okay.
Because if you take any number and you cube it, multiply it by itself 3 times, you get a real number back. And then if you multiply that by 9, you still have a real number. The problems are going to
So
be
0 is then a real number.
0 is a real number.
Because like if you
yes.
multiply, yeah.
Things that you have division by 0, like if you have 5 over 0 or 7 over 0, that's not a real number. Or if you take the square root of a negative number, that's not a real number. But any of the numbers we think about, you know, just normally 1, 1/2, 0, -7/5, those are definitely real.
So just not fractions. Is that what you're saying?
No, fractions are real numbers also. 7/5, 2/3, 6/17, anything like that, that's a real number. Things that are not real numbers are when you have like a 5 over 0. That's not a real number. You can't divide by 0. If you have the square root of -4, that's not a real number. Okay, that's an imaginary number, which we will talk about imaginary numbers a bit later in the course. But right now, for it to be a real number, well, anytime number, if you're taking the square root, it has to be at least 0 underneath the radical. All right, let me stop this share for just a second and go back and share the homework page again. Those last two are fairly similar, but I wanted to look at this very last one because it's one that's just a little bit different in the setup. So I wanted to look, this is functions given graphically. Are you guys seeing those two pictures?
Yes, ma'am.
Or, well, it's not really two pictures, it's one, but yeah.
Yeah.
Okay, so let me magnify that just a bit. Okay. So they want us to figure out what f plus g of 4 is graphically. And so we have f of 4 and g of 4. We're going to have to find those using the function itself. Okay, so f is the red line and g is the blue line, according to the way they have them identified. And so f of 4, remember, graphically speaking, f of 4 is just the y value when x is 4 on the f function. So, I can't wait for my new pen to come in. I hope it helps. All right, so on the f function, so we've got this horizontal line right here. If you go to x is equal to 4, which would be about here, not about, that's exactly x equals 4, what's the y value that goes with the f function when x is equal to 4?
-2.
I think you're looking at g.
2.
I'm sorry, 2.
Oh, that's okay. It's that one you have to pay really close attention to because the G function is the blue function. But yes, the F function, since it's the red function, you'd be looking at this point right up here. And I lost my drawing. So it would be this point right here. Well, it will not draw on that. So there we go. And that Y value is 2. And then G of 4, I think you already told me. So G of 4 would be what you get when you look on the blue line. And that point is right down here, and that's -2. Okay. Does everybody see where we got those two values?
Yes.
All right. So F of 4 plus G of 4 would be what? That's just going to be 2 plus -2. Maybe I should always write on the screen because that for sure slows me down a bit, doesn't it? So if we get 2 plus -2, that's just going to be 0. And so our solution to that one, type in 0 and hit enter and get a job. Yay. Now, what if I asked you that same set of graphs? I would like for you to find F plus G of 0. That's a 0, sorry. Okay, so same picture. I just want you to find F plus G of 0 and hold on to it for a second, and then we will compare our answers in a minute. I'll try to give you 2 minutes to finish that one, and then I'll ask for input. All right. Would anyone be willing to tell me what they got for f of 0?
I got f of 0 would be 2.
Good. 2. Now remember, I heard
Oh
some
yeah,
of,
that's 2.
yeah, because it's the red line. Yeah.
I gave the final answer.
Oh, gotcha. You were just ahead of us. All right. What about g of 0?
Yeah, sorry.
Oh, that's fine. G
That's
of
6.
0 is 6. Good, because we go to the blue graph, we find x equals 0, and we count the units to the blue line, and it looks like it is indeed at 6. So f of 0 plus g of 0 will be 2 plus 6 or 8. Excellent job. All right. So actually the only section we're today